Good morning, JD Parker students, and welcome to day 9 of virtual learning. Today is Thursday, April 9th. And we are finishing up with a standard today in F2.4. We are going to continue reviewing it on and off, but today is a day you're going to take your mini assessment. And reminders, there is no class tomorrow. You do not need to log in again until Monday. There is a holiday tomorrow called Good Friday, followed by Easter Sunday. And I hope you guys have a wonderful weekend. And I love this view right here. And the quote says that every accomplishment begins with the decision to try. And the harder the accomplishment, the bigger decision it is to try. Sometimes people don't want to try because it's just going to be too hard. But that accomplishment, when they do succeed, has big rewards to it. And here is the paper you worked on yesterday. So I'm going to go through it pretty quickly. I'm stopping a couple times just to show you different strategies. But these are the word problems, and word problems get tricky because sometimes you're not exactly sure if you're adding, subtracting, multiplying. This paper is multiplication. Some of the review on the back is not. So you have a shrub. A shrub is like a bush, is 1/2 feet tall. A small tree is 3 times that of the shrub. How tall is the tree? So here you can see they skip counted addition. This is almost like a number line, or actually it's almost like using just a model. You have 1 whole plus 1 whole plus 1 whole, so that's 3 wholes so far that you see right there. And now you have to add 2/3, 2, 4, 6 thirds, and when you divide out 6/3, you will end up getting a 2 for this because 3 can pull 2 3s out of 6. 3 times 2 is 6. So this ends up being 3 wholes plus 2 wholes, which equals 5. So the tree is 5 feet tall. You run 1 3/4 of a mile each day. Your friend runs 4 times as far as you do. Let me make that less blurry, hopefully. Okay, so you have 1 3/4, and we're going to do that 4 times. So you can distribute out the 4 times 1, and then the 4 times 3/4, and get your answer. Or you could turn this mixed number into a fraction by taking the denominator, timesing the whole, and adding in the extra for the numerator. So 4 times 1 is 4 plus 3. This will be 7/4 when you switch this back around times 4. Well, this is also a numerator because it is a fraction. 4 times 7 is 28/4. And then you can divide that out, or you could leave it in fraction form. But if you divide that out, 4 times 7 gives you 28. So 7 miles. Wow, that's pretty far. At the grocery store, Alaya, cool name, buys 1 1/3 pounds of ground turkey. Tasha buys 2 times as much as Alaya. How much ground turkey does Tasha buy? Well, since you're multiplying times 2 here, this distributed property would be super easy. So take your whole times your whole. So this is 1 whole times 2, which equals 2. And then multiply 2 times 1/3. 2 times 1/3 equals 2/3. So you get 2 2/3 pounds. Or you could do LBS. So if you wanted to also skip count by 2, that's easy. And a number line would have been easy also. Your first stop, your first hop would have been 1 and 1/3. Your second hop, because you have to hop 2 times, would be then 2, double it, and 2/3. And then when Nathan's mother drives him to school, it takes 1/5 hour. When Nathan walks to school, it takes him 4 times as long to get to school. How long does it take Nathan to walk to school? Well, it takes him 4 times as long. 4 times 1/5. You can multiply that straight across. Remember, this is like a numerator because you can always put the whole over a 1. 4 times 1 is 4. And then 4 times 5, 1 times 5 is 5. 4/5 of an hour. Okay, and on the back page, we have a Wilson storm petrel is a small bird with a wingspan of 1 1/3 feet. A California condor is a larger bird with a wingspan almost 7 times as wide as the wingspan of the petrel. How about oh, about how wide is the wingspan of the California condor? Okay, so they're using the word about, which tells me they're estimating or rounding, but I believe this is the reason why they are saying it here because they are estimating it is almost as big as this. I do see the exact answer below. If you were to round, so we are going to figure out the exact answer because here they're telling you that they are already doing their rounding. They're saying it's almost 7 times. So 7 times 1 and 1/3. Well, if I was to distribute the 7 to the 1 and then the 7 to the third, I know that 7 times 1 equals 7. 7 times 1/3. Well, I could multiply straight across because this whole number is like a numerator, 7 times 1, and then 1 times 3. And then I would add these two together. So if I have 7 and 7/3, this is already bigger than 1. So I need to divide this out and get a mixed number so I can add my mixed number to my whole. I drop my numerator inside the box and I leave my denominator as my divisor because he's telling you what the whole is cut up into or what you're pulling out. So they're basically the same thing. So think he's pulling out now 3s because the whole is a 3. 3, one time would be 3. He pulls out 2 3s. He gets a 6 and 1/3. Now I'm going to add my 7 to 2 and 1/3, and I will get 7, 8, 9 and a third. And then number 2, the walking distance from the Empire State Building in New York City to Times Square is 9/10 of a mile. I have done that walk before. It seemed a lot further. The walking distance from the Empire State Building to Sue's Hotel is 8 times as far. About how far is Sue's Hotel from the Empire State Building? So it is about 8 times as far. I'm looking at 9/10, and 9/10 is pretty close to 10/10, which would be a whole, which would tell me it's going to be close to 8 miles. So we have a fraction we need to multiply out. So we have 8 times 9 is 72 tenths. If I was to divide that out, 10 is my denominator. So that's telling me how many holes I'm pulling out. My divisor is a 10. I jump inside the box and I'm going to pull out 7 10s because 7 times 10 is 70. And I'm left with 2 left over my worker, my divisor. So 7 and 2 tenths. There you go. All right, so this is a review. This is a review of 8-4. Which of the following is not equal to 3 times 2/4. Ooh, I love this problem. So this is telling me different ways I could solve it. So let's see. If I was to, oh, they have a fraction here. If I was to turn him into a fraction, I would take the denominator times the whole, that's 4, times 2, which is 8. Add in my numerator. Don't forget this little dude up here. So I have 8 plus 1, which is 9/4. So this and this is the same thing. So I'm looking for one that's not equal. And here is the distributive property, which I've been doing all along with you. 3 can multiply times the 2 first, and then 3 can then multiply times the 1/4. And then you add those two together, and you will get the answer. So this would also be a way to solve it. And then 6 3/4, looks like they went ahead and they solved it. So let me go ahead and solve it. And we can see 3 times 2 is, let's use this one here. 3 times 2 is 6, and then 3 times 1 is 3 with a denominator of 4. And add those two together, 6 3/4. No, this is right. Oh, but this is not right. So this is just saying 3 times 2, and then they add in the 4th. You can't just add that in. He also has to be multiplied by the 3. So what's wrong with this picture is the 1/4 needed to also be multiplied by the 3, because it needs to be 1/4 3 times, and it needs to be 2 3 times. So D is the correct answer. That is not correct to solving that one. At the bake sale, seems so blurry, Ron sells 7/8 of an apple pie and 5/8 of a cherry pie. All together, how much pie does he sell at the bake sale? All together means, well, you're putting it together. You are adding. So 7/8 of an apple, 5/8 of a cherry, add that together. And when you are adding fractions, as long as the denominator is the same, you leave it alone. And then 7 plus 5 is 12. So here is your answer right here. You could have reduced that if you want by dividing the top and the bottom by 4, but you don't need to. And then number 5. Oh. On a ruler, which measurement is between 3/16 and 7/8? So 3/16 on a ruler, I need to know between 3/16 and 7/8. Now I'm going to find a common denominator. As you can tell, this was 2 lessons ago. 2 chapters ago. So a common denominator for 7/8, because I need to find what goes in between. And they do have different denominators here, so I need to find which one they have in common. So factors of 16 would be 2 and 8. But I can't reduce the 3. It's prime and it can't be divided by 2. But 8 could be multiplied by the 2. And remember the saying, whatever you do to the bottom, you have to do to the top. If you're trying to find an equivalent equal fraction, you have to make sure you're being fair to the numerator and denominator by doing exactly the same thing. So 8 times 2, it's a 16. And then 7 times 2, it's a 14. So I made the same exact fraction in a different form. I just doubled it to get an equal of 7/8. 14/16 is the same. So I'm going to get rid of this now so it doesn't confuse me. I need to know which measurement is between 3 to 14/16. So from now, that should seem pretty easy. So I see 1/16. That's way down here. 1's way down here. So that's not right. 1/8, well, that does not have a 16, but if I double 8 and I double 1, I'll get 2/16. So that'd be right about there. So that's not right. And then a 15/16D would not be right because that would be a higher than this 14. That would be right over there, right about here, 15. So that's not right. But 11/16, 11 is definitely in between 3 and 14. Would fall about right there, 11/16. So C is correct. And then last, which of the following numbers is a composite? Remember, prime numbers are numbers that can only be found by multiplying it times 1. So 3 is prime because the only way to make 3 in multiplication is to times 3 times 1. 2 is prime. 5 is prime. And so a composite number is opposite. A composite number means you have 1 times that number will equal that number. And then you also have another one. 2 times something will equal the same number, or 3 times. So composite simply means there's another way to multiply factors together to get the number. All right, I see number 1 here, and this is a big no-no. 1 is not prime, and 1 is not composite. It's doesn't fall into any categories. Neither does 0, but 1 is not an option for prime or composite. That's a trick question, so get rid of that. 2 happens to be the only prime even number there is, because every other even number in the world can be 2 times something to give you another number, except for 2. The only way to make 2 is 1 times 2, and then flipping it, that wouldn't count. That would be repetitive. So 2 is prime, and 3 is prime. 4 is a composite because there is 2 ways to make 4. 4, you can say 1 times 4 equals 4, and then 2 times 2 equals 4. That's 2 different ways I can make the number 4 by multiplying, which means that is composite. And prime means you can't find any other way than a 1 times that number. Okay, so that is the end of this review. Now, I did ask you guys just to do the even numbers on both sides. So hopefully that'll give you enough time to jump into your mini assessment for today. Do the best you can, and then I will review that on Monday with you guys. Enjoy your weekend. Goodbye.